Our next unit, chapter 6 or unit 6, is on functions. So let's take a look. Did you notice fun in functions? Let's figure out what is a function. A function is a relationship with one or more variables. We know that word, which is just our letters, usually our x and y, where each input has exactly one output. Input, output, variables x and y. Could you also add next to input another name for input? Maybe you've not heard of this word before, but it's domain. And another word for output is range. So a function is a relationship with one or more variables where each input has exactly one output. So in other words, each x value, which is the input, each x value is only allowed to correspond with one y value. So that's an important part. Each x value is only allowed to correspond with one y value. So in a function, none of our x values can repeat. Let's see what this looks like. So what you're seeing here is called a mapping diagram. So our first set of numbers, our first box, that's the input. Our input is also known as the domain, and it's also known as our x values. Okay, so according to our definition above, in a function, none of the x values can repeat. So if we're looking here, did you notice that the 4 is repeating? So that must mean that this is not a function. Also, over here, these are the outputs or the range or the y values. Okay, so I want to prove something to you. So I thought we would graph these to justify it. So let's take our inputs and our outputs. So if we graph our first ordered pair, the 2 and 1, so 2 on the x and 1 on the y. So if we graph that point, that shows up right there, our first point. Our next point is 4 pairs with 2. So over 4 and up 2 is right here. Our next point is 6, 3. So over 6 and up 3. And then over 4 and up 4. Okay, so those are all of those points. Okay, so here they are. So the reason this is not a function is the input of 4 has 2 outputs. So if I drop a line right here, these 2 points hit my line twice, and we'll get to that. It's called the vertical line test. Okay, so function or not a function, the first one is not a function, and it happened right here when these 4s repeated. So to be a function, every input has to have exactly one output. Let's look at the next mapping diagram. So now this looks unusual, but we have an input of 2 or an x value of 2, and then all of these outputs. Do you think this is a function? Every input has exactly one output. Let's see what this looks like on the graph. So if I go over 2 and up 2, I have a point right here. And then over 2, up 3, is right here, and over 2 and up 4 is up here, a little bit crooked there, and over 2 up 5. So, oh my. So the input of 2 has too many outputs. Look at all of those outputs. So if I dropped a line down here, you can see like an undefined line. The input of 2 has 4 outputs. So this is also not a function. So to be a function, it must have a one-to-one relationship. So none of these are going to be functions. Okay, you can also check to see if a graph is a function. With, you could do what I'd mentioned before with a vertical line test. I think you're going to like this. I like this test. So here's how this works. If you draw a line through a graph and it touches 2 or more points on the graph, then the graph is not a function. It's a pretty simple, straightforward test. You just have to remember that it's called a vertical line test, so your line must be vertical. Okay, let's see how this looks. Okay, so I made this purple line. This is my vertical line to do the test. So now what we're going to do is we're going to move the line across the graph. And what we have to do is see if the graph touches 2 or more points. Okay, so right here, the line only would touch once, but when I move here, it's touching in multiple spots. It's touching the line here, here, and here. So going back to my original purple line, now I have yellow dots on it, as I move it across, it's going to touch in several places. So this first graph does not pass the vertical line test, so I can go ahead and circle that this is not a function. Every input does not have exactly one output. Okay, so let's try the vertical line on our second graph. So as I move the line across the graph, does the line on the graph touch my vertical line only one spot each time? Yes. This is passing the vertical line test. So this is an example of a function. So we can circle function. Okay, let's check the third graph. Ignore that the circle is coming with me, sorry. Okay, let's check this. Does it pass my vertical line test? Well, it's a circle, and yeah, it's hitting the line in 2 places. So our third one does not pass the vertical line test. So the third one is not a function. Okay, so going back here, if you draw a line through the graph and it touches 2 or more points, then it is not a function. Okay, and our last look is function tables. So we looked at mapping diagrams and graphs, and now we're looking at tables. You can tell a function is linear or nonlinear from a table of values. So that's our first word to put in there, a table, or it's like a chart. An input and output table can be used to find x and y values of a function. Again, those words, the input are the x coordinates and the output are the y coordinates. And let's also put in the words domain and range right underneath those. So we have to get used to all those names. The x is the input or the domain, and the y is the output or the range. Okay, so again, every input has to have exactly one output. So when we look at the inputs, these all have to be different. And it looks like they are. So this is a function. And let's look at our inputs in our second table. Do you see right here that repeats? It says 4 is 7 and 4 is 14. So this table is not a function. I want to take this a step further. You don't have this on your paper, but I want to show you what it looks like on a graph. And I want to do the vertical line test, and I want to see if it's linear or nonlinear. So stick with me. So here's the same table of values, the inputs and outputs. And I just wanted to take a minute to show you on a graph what this is going to look like. So these are ordered pairs. So we're going to go on our graph, -2 and 0. So let's plot that point. And again, you don't have this, but I just made it for you to see. Okay, so that point's graphed. Okay, -1 and 1 is here. Okay, so I did that point. 0, 2 is here. 1 and 3 is there. And 2 and 4 is there. Okay, so my graph might be a titch off here, but do you see I created what's called a linear function? It's a straight line, and if I tried that vertical line test, then it would pass. So this would definitely be a function. For every input, there's exactly one output. So I do like to take a table of values and put it on a graph just to check. So let's graph the second one. I'm not going to have enough space for 25 or even 14, but let's just take a look and graph what we can. So over 3, 3, 0, that's going to be here. 4 to 7, 1, 2, 3, 4, is right there. 5 and 10 is up here. And 4 and 14 would be about right here. And then 10 and 25 would be like way up there. Okay, now what I wanted you to see here is that the place where the input of 4, it has two values. It has 7 and 14. So this is definitely not a function because we have this like undefined slope. So when I graph it, you can see that this is not going to pass the vertical line test, but this one does. This one over here is linear. Everything's constant. And this one, if I connected these, would curve. So this one is called nonlinear. But this one is not even a function. This is not a function.